Sometimes science encounters moments when the familiar picture of the world begins to crumble. Montrell's mysterious experiment was just such a moment. It was a bold challenge to fundamental laws that seemed to have been written once and for all. Just 100 years ago, ether, the elusive medium in which light was believed to travel, was consigned to scientific oblivion after the Michelson-Morley experiments. Scientists then decided that it did not exist, period. But the history of science knows that a period often turns into a comma, followed by the most interesting part. The Monterey Project is not just an attempt to resurrect an old idea, but almost a challenge to the universe itself. Its authors risked looking into the very heart of the vacuum, asking, what if we've been wrong all this time? And the answer they got was very intriguing. Today we will talk about a bold experiment that may have brought the ether back into the scientific agenda and has already divided the scientific community into two camps: enthusiastic admirers and cautious critics. If science had its own mythology, the Michelson-Morley experiment would occupy the place of a thunderous myth about how one bold test can kill an entire concept. The end of the 19th century. Imagine a world full of confidence that light, like sound, must propagate in some medium. This medium was called ether, an invisible, infinitely light substance that filled all space. Ether was not just a hypothesis, but part of the scientific worldview, the foundation on which physics was based at the time. In 1887, Albert Michelson and Edward Morley built an interferometer that was gigantic for its time. The instrument was so sensitive that it seemed it could detect even the whisper of ether. The essence of their experiment was almost poetic. If the Earth moves through the ether, then the speed of light should change slightly depending on the direction, like a swimmer swimming against or with the current. But the result was stunningly banal. There was no difference. Light behaved as if there were no ether at all. It was a blow to physics. Theories collapsed. Textbooks became obsolete in an instant. From that moment on, the ether became a ghost of science. It was buried more than once. Noble's Troughton experiment in 1903 showed that a moving capacitor does not experience ether wind. Shimura's experiment confirmed that even with huge metal barriers, there was no difference in the speed of light. And then Einstein's theory came along, offering a radical solution. No ether was needed. Space-time itself was the arena for light and gravity. It seemed that this was the final word on the matter, but as is often the case, science does not like definitive conclusions. In the 20th and 21st centuries, individual scientists and entire laboratories continued to search for at least a hint of ether, sometimes under other names, such as physical vacuum, quantum field, and zero-point field. In the 1960s and 1970s, more accurate versions of Michelson's experiment appeared, using lasers and vacuum chambers. And again, nothing. But in parallel niches of science, new and bold ideas were born. Some physicists suggested that ether might not be a motionless fluid, but a dynamic quantum-excited structure, and therefore eluded old-style detectors. It was this idea that became the foundation for the Monterey Project in the 21st century. According to its authors, this experiment was the first to use vertical measurements in special conditions under which the ether effects simply could not remain hidden. So we have reached a point where history is taking a dangerous turn from denial to a possible revival of the idea. Ether, this dead king of physics, is suddenly rising again on the chessboard of science. And perhaps this time the game will end. Otherwise, there are experiments that are conducted quietly in the semi-darkness of laboratories, known only to a narrow circle of specialists. And there are those that sound like thunder from a clear sky and become the subject of fierce debate even before all the details are published. The Monterey Project belongs to the second type. It is not just scientific work, but a bold challenge to all of modern physics. A group of enthusiasts armed with modern technology decided to take a fresh look at the question of ether. The very name Montirey is almost mystical, like the name of an expedition to uncharted lands. And indeed, at its core, the experiment was an attempt to look beyond the familiar scientific horizon. The authors decided that since the classic Michelson-Morley experiments did not detect ether, it was necessary to change not only the sensitivity of the equipment, but also the geometry of the search itself. The main innovation was the vertical dimension. Unlike classical experiments, where interferometers rotated in a horizontal plane, The Monterey apparatus worked vertically, as if the researchers had decided to check whether the ether reacted to gravity and height. The idea was simple and ingenious. If the ether really has structural properties, then changing the position of the setup relative to the center of the Earth could affect the behavior of light. The setup consisted of a high-precision optical complex capable of detecting the slightest changes in the diameter of Newton's interference rings. The experiment was conducted at two fundamentally different heights, just a few meters above the ground and at an altitude of more than a kilometer. According to the authors, this difference allowed them to detect possible traces of interaction between light and the ether that horizontal experiments had missed. The result was stunning. During the ascent, the installation recorded a noticeable change in the diameter of the rings, so much so that the authors began to talk about variations in the speed of light depending on its position in space. And here emotions run high. If this is true, then light is not an absolutely constant quantity, and its characteristics depend on the medium through which it moves. Of course, such a statement sounds like scientific provocation, because the speed of light in a vacuum is one of the pillars of modern physics, enshrined in the definition of the meter and built into theories from Einstein to quantum mechanics. And now someone says, wait, we have data that this is not the case. It's like someone proving that gravity sometimes forgets to pull objects down. Critics, of course, immediately pointed to possible errors: temperature fluctuations, vibrations, atmospheric pressure, mistakes in interpreting the data. But Monterey's team insists that the conditions were carefully controlled and the results are reproducible. What's more, they are already preparing a series of follow-up experiments that, they say, will finally settle the question: is ether real or an illusion? In any case, the very fact that such a project has emerged has shaken the scientific community. After all, Monterey is not an armchair discussion, but a real attempt to step where many are afraid to even look. In this sense, the creators can be called both madmen and prophets. Some see them as dangerous destroyers of foundations, others as daredevils willing to risk everything for a grain of truth. To understand the scale and audacity of the experiment, you need to literally stand next to the Montireya installation and follow the scientists through every step, from preparing the equipment to taking the final measurements. Everything was thought out down to the smallest detail, because the slightest mistake could have ruined the results or, conversely, created a false sensation. In general, we will now take a detailed look at the experiment itself. The first stage is preparation. The team assembled a highly sensitive optical setup based on the principle of observing Newton's interference rings, the thinnest light structures that arise when light is reflected between two optical surfaces. These rings are sensitive to microscopic changes in the optical path of light. Therefore, even the slightest influence of ether, if it exists, should have manifested itself. The setup was calibrated in laboratory conditions, where temperature, humidity, and vibrations were strictly controlled. The second stage was a two-level placement. Monterey's main trick was that the measurements were taken at 2 points with sharply different heights. The first was just a few meters above the ground, where conditions are as stable as possible and the baseline state of the rings can be recorded. The second was at an altitude of more than a kilometer above sea level, where the setup was delivered disassembled and then reassembled. The difference in height was supposed to change the gravitational potential, and if ether existed, reveal its influence on the propagation of light. The third stage was data recording. At each height, a series of measurements were taken using a laser light source passing through an optical block. The researchers recorded the diameter of Newton's rings with extreme precision using digital photography and spectral analysis. Every micrometer detail was important here. The rings literally expanded or contracted as conditions changed. It was this phenomenon that the team considered a key indicator of the presence of ether. The fourth stage was to control external factors. To prevent critics from attributing everything to atmospheric pressure or temperature fluctuations, the researchers created a virtually airtight optical chamber with controlled pressure and temperature stabilization. Moreover, the measurements were taken at different times of the day to rule out the influence of random daily fluctuations. The result, when comparing data from low and high points, stable differences in ring diameter were found, so large that they could not be explained by instrument error. If the interpretation is correct, this meant that the speed of light in these two conditions was slightly but measurably different. It was this fact that the Monterey team interpreted as direct evidence of the interaction of light with the physical ether. Imagine looking through the lens of the instrument, seeing the rings suddenly become wider, and realizing that you may now be holding the key to a mystery that science had long considered closed. It's a mixture of excitement, disbelief, and the feeling that you are standing on the edge of a scientific abyss, peering into the darkness of the unknown. Why is this unique? No one had previously attempted to search for the ether of a vertical plane with such a high degree of accuracy. Classic experiments chased it horizontally. But if ether is really connected to gravitational potential or quantum vacuum density, only this geometry could bring it to light. As soon as Montirey's results became known to the scientific community, everything started to change. Some rushed to applaud, others criticized. Let's look at the arguments of the supporters. The main argument of the supporters is the uniqueness of the methodology. The vertical orientation of the experiment allowed us to look at the problem from an angle that no one had tried before. If ether is really connected to gravitational potential, then this approach could have yielded positive results, while classic horizontal experiments were simply looking in the wrong place. Extreme sensitivity of the equipment, the use of Newton's interference rings in combination with modern digital analysis methods allowed for tremendous accuracy. For physicists, this is like noticing that a hair on your head has grown 1/100th of a millimeter. Control of external factors. Montirey's team provided a sealed chamber, temperature stabilization, and pressure control, which ruled out classic excuses such as, "It's all because of the weather." Repeatability. According to the authors, the measurements were reproduced under different conditions and at different times, and reproducibility is one of the cornerstones of scientific agreement. Supporters see this experiment as something that could restore ether to its rightful place in physics. For many, it is almost an act of scientific justice. It proves that previous experiments were incomplete, rather than categorically disproving the concept. Now let's discuss why many are skeptical about the experiment. Temperature artifacts. Critics are convinced that even a perfectly stabilized setup can still pick up thermal gradients, especially when transported to different altitudes. Microscopic thermal deformations can affect the size of interference rings, atmospheric pressure, and vibrations. Moving the setup, especially to an altitude of more than a kilometer, can cause micro vibrations and shifts that, with such sensitivity, can easily be confused with the ether effect. Ambiguous interpretation. Even if the diameter of the rings changes, this is not necessarily related to the speed of light. There are dozens of factors that affect the optical path, from humidity to microstresses in optical elements. Conflict with fundamental physics. If Montirey's results are taken at face value, not only school textbooks will have to be rewritten, but also the very foundations of modern physics, including special and general theories of relativity. Skeptics believe that such claims require evidence 10 times more rigorous than usual discoveries. The sensational error effect. The history of science is full of examples where what seemed like a revolution turned out to be a trivial methodological error. Skeptics fear that this is just another illusion of an epoch-making breakthrough. So who is right? At the moment, both sides stand their ground. Supporters demand further research and large-scale international verification. Skeptics insist that until independent laboratories reproduce the effect, it is premature to talk about the proven existence of ether. If Montirey's results stand up to scrutiny, we could witness the most significant scientific revolution of the 21st century. Imagine that something that has been considered a scientific ghost for decades suddenly receives a passport stamped with the word exists. For some, this is a cause for celebration, while for others, it is a nightmare, as it would mean breaking established theories. The first thing we'll have to do is rethink the fundamental laws of physics. Not just add a couple of paragraphs to the section on light, but completely rebuild the concept of space, time, and the interaction of matter. If ether exists, then there's a huge gap in our understanding of the universe. And that's not just a little renovation, it's a complete overhaul of the building of science. History shows that as soon as we discover a new environment or phenomenon, Technologies begin to spring up like mushrooms after rain. If ether is material and interacts with matter, it could become the basis for ultra-safe long-distance energy transmission, ultra-precise navigation without satellites, and new types of engines that use the very structure of space. Today, this sounds like science fiction, but so did the first ideas about electricity in the 15th century. Ether could be the missing piece of the puzzle in explaining dark matter and dark energy. Perhaps it is the invisible fabric that connects galaxies and determines the fate of the universe. If this is confirmed, current cosmological models will have to be recalculated from scratch. The discovery of ether will go far beyond the laboratory. It will bring back discussions about the medium that connects everything in the universe, about the unity of matter and energy. New philosophical schools will emerge, old concepts will be revived, and some will even see in the ether confirmation of ancient myths and esoteric teachings. Technologies based on the ether could become the new atomic weapon in the economy. Access to them will give the state or corporations an unprecedented advantage. Therefore, not only scientists but also intelligence agencies will be monitoring research. Funding in this area could increase tenfold. There is also a dark side. If ether is confirmed and old theories prove to be wrong, part of the scientific community may simply refuse to accept it. History, of course, knows examples when discoveries cause protracted conflicts between old and new schools of thought. Such a split can slow progress for years. The bottom line is that Monterey is like a stone thrown into the smooth waters of science. The ripples could reach the most distant shores, from school classrooms to space observatories. And who knows, perhaps we are already on the threshold of an era where ether will cease to be a word from old textbooks and become part of everyday reality. We have come a long way from the Michelson-Morley experiments that buried the ether until today, when a group of scientists decided to revive this ghost and perhaps give it a second life. Their method, unconventional and bold, has produced results that are too significant to be dismissed. Yes, skeptics are already ready to pick the experiment apart. Yes, there are still dozens of tests ahead, but the very fact that such a result has appeared has already done its job. It has shaken the scientific world like a powerful wave raised by a sudden storm. Supporters see this as a step towards a new physics in which ether will take its place as a real, measurable medium. Opponents believe that we are witnessing yet another sensational mistake and that soon everything will return to normal. But one thing is clear. Montirey has become a catalyst for discussions that we have not had for decades. Perhaps in years to come, we will tell our students that it was this experiment that marked the beginning of a new era, an era where space ceased to be emptiness and became the living fabric of the universe. Or maybe we will remember it as a beautiful but unfulfilled dream. In any case, Montirey has already made history, and from now on, it will be much more difficult to ignore the ether than it was yesterday.